Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. In my last video about the basics of algebra part 2, I discussed about the concepts of polynomials and also some fundamental operations upon them. That is how to add two polynomials, how to subtract two polynomials and how to multiply two polynomials. Now here today in this video, I shall be mainly discussing about the division process among polynomials. That is how to divide one polynomial by another polynomial. Now as I discussed in the previous video that whenever we add two polynomials or whenever we subtract from one polynomial from another or whenever we multiply two polynomials, the result is always a polynomial. But the same is not true in case of division. That is, if you divide one polynomial by another one, the result may or may not be a polynomial. So when the result will be a polynomial, if the degree of the numerator polynomial, that is the dividend polynomial, is more or equal to that of the degree of the divisor polynomial, then only the quotient will give you a polynomial. Let me illustrate this with an example. So let us consider two polynomials, say one fx given by x minus 2 and another one say gx given by x cube minus 3x square plus 4x minus 3. So let us start with these two polynomials, one fx, one gx. So as you can see that fx is a linear polynomial, that means it is of degree 1, and gx is a cubic polynomial, its degree is 3. So if now we divide the polynomial gx by the polynomial fx, so if I divide gx, that is x cube minus 3x square plus 4x minus 3, if I divide this by the polynomial fx, which is x minus 2, then this polynomial is known as the dividend polynomial. This is the dividend polynomial, and here we have the divisor polynomial. So as you can see here that the degree of the dividend polynomial is strictly more than that of the divisor polynomial. Then the resultant polynomial, which we call the quotient polynomial, or you can say the resultant expression, which we call quotient, will yield a polynomial. Now how to carry on the division process? So first we have to write the result here. Our quotient polynomial, we shall write it here. Now to form the quotient polynomial, first you note the highest degree term of the dividend polynomial. Now while writing the dividend polynomial, we have to maintain the degrees of the terms in descending order. That is, first you write the highest degree term, then the next lower degree, then the next lower degree, and finally the 0 degree term. That is the constant term. So always maintain a descending order of degrees while writing the dividend polynomial, and the same is true for the divisor polynomial. Now the first term of the quotient polynomial here is determined by the adjustment with the first term of the divisor polynomial, such that by multiplying these two, we shall get the first term of the dividend polynomial. What I mean is, we have to find an expression involving x, which when multiplied by x, that is the first term of the divisor, yields the first term of the dividend. So here the first term of the dividend polynomial, or the highest degree term you can say, is x cube, and the first term of the divisor polynomial is x. So what we have to write? We have to write here x square, such that while multiplying x square with x, that is the first term of the divisor, gives us the first term of dividend, that is x cube. So that is the process of finding the quotient. So first we write a term containing x, which when multiplied with the first term of the divisor gives us the first term of the dividend. Now we multiply x square with the entire divisor and write it here. So x square into x gives us x cube. Then x square multiplied by minus 2 gives us minus 2x square. Then we subtract the two expressions. These two rows we have to subtract. That is, we have a polynomial in the first row, another polynomial in the second row. We have to subtract these two polynomials. So as we discussed in my previous video, that while subtracting two polynomials, we have to change the sign of all the terms in the second row and then add them together with the change sign. So here x cube minus x cube, these two get cancelled. These two terms get cancelled. So what we are left out with, minus 3x square plus 2x square. So you have to consider the change sign now. Minus 3x square plus 2x square, which gives you minus x square, and also write down the remaining terms, that is plus 4x and minus 3 from the first row. So this is the result if you subtract these two polynomials. Now again continue the same procedure. Now here you see we have a quadratic polynomial, that is a polynomial of degree 2 whose first term is minus x square. So again we have to adjust some term here which upon multiplying by x, that is the first term of the divisor, will give you minus x square. So clearly the term will be minus x, because minus x when multiplied by x will yield minus x square. So again we multiply minus x with the entire divisor and write it here. So x multiplied by minus x gives us minus x square, then minus 2 multiplied by minus x gives you plus 2x. Here the sign becomes plus, minus minus is plus, so plus 2x. And again we follow the subtraction, so we change the sign in the second row. Now these two terms plus x square minus x square cancel each other. We are left out with 4x minus 2x, that is 2x. Mind that you have to consider the change sign here. 4x minus 2x, that is 2x, and from the above row we write minus 3. Again continue the same procedure. Now we have to adjust a term here which upon multiplying with x shall yield 2x. So clearly this is plus 2. So if you multiply 2 with the entire divisor, we have 2x, then minus 2 into plus 2 gives you minus 4. And again subtract these two, change their sign, minus plus, these two terms get cancelled. So finally we have minus 3 plus 4, so which is plus 1. Now you see at this step we have a constant term. A constant term is a polynomial of 0 degree. So here the degree of the polynomial becomes strictly less than that of the divisor polynomial. So when the degree of the polynomial after subtraction becomes strictly less than the divisor polynomial, here divisor polynomial is a linear one that is having first degree, and here we have a 0 degree polynomial, then the division stops. At this stage the division stops, and this is known as the remainder, and here this polynomial is known as the quotient. So therefore when you divide gx by fx, the quotient is a polynomial which is given by x square minus x plus 2, and we get the remainder as 1. It may so happen that the remainder becomes 0 when all these terms get cancelled each other. You may have 0 as a remainder, that is all the terms will cancel in the last step. So if the remainder is 0, then we say that gx is exactly divisible by fx, or fx is said to be a factor of gx. So this is when we say that a polynomial fx is a factor of a polynomial gx, that if you divide gx by fx and the remainder becomes 0, then the divisor polynomial is said to be a factor of the dividend polynomial. But here we clearly have a non-zero remainder. So here the divisor polynomial is not a factor of the dividend polynomial. So this process of division is known as long division. We call this a long division. So here we have, this is the quotient, this is the remainder, and always note one thing, that if you divide gx by fx, the degree of the quotient will be the difference of their degrees, that is degree of gx polynomial minus degree of the fx polynomial. Here gx was a polynomial of degree 3, The dividend is a polynomial of degree 3. The divisor is a polynomial of degree 1. So the quotient is a polynomial of degree 2, which is difference of the degrees of the dividend and the divisor, that is 3 minus 1, 2. So the degree of the quotient polynomial will be the difference of the degrees of the dividend polynomial and the divisor polynomial, and the remainder will always be a polynomial of degree 1 less than the divisor polynomial. So here the divisor is a linear one, that is degree 1, so the remainder is a constant term having degree 0. Now the same method of division, that is instead of following the long process, we can also find the quotient and the remainder by a short technique known as synthetic division. So let me now explain the method of synthetic division by the same technique, how we can find the quotient and remainder in a more faster way. But mind that this process, synthetic division, will be applicable only when the divisor will be a linear polynomial. Likewise, in this example, our divisor polynomial fx is a linear polynomial. Then only this shortcut method, which we call synthetic division, is applicable. So how to perform the synthetic division? This is known as synthetic division. Now to perform the synthetic division process, what is synthetic division? Synthetic division is a method by which we can find the quotient polynomial and the remainder polynomial in one step if you divide a polynomial by a linear one, by a linear polynomial. So mind that here the divisor polynomial should be linear in nature. So let me illustrate the synthetic division with the help of these two polynomials only. So first we write the coefficients of the dividend polynomial in a complete row form. So what I mean by a complete row form, that means that first you have to make the dividend polynomial a complete in a complete form. Complete form means starting from the highest degree terms, all the lower degree terms must be present. So here gx is already in the complete form because we have third degree term, second degree term, first degree term as well as 0 degree term. So we write the coefficients in descending order of their degrees. That is, first we write the coefficient of the highest degree term, that is first degree term, which is 1 plus 1. Next to write the coefficient of the second lower degree, that is second degree term, which is minus x. So mind that while writing the coefficients, we have to consider the sign together with the new number. So this is minus 3, the coefficient of the second degree term. Then we have the coefficient of the third degree term, that is plus 4. And finally, the constant term minus 3. So first we have to write down the coefficients and the constant, including the constant of our dividend polynomial, forming this a complete one, a complete polynomial. In case the polynomial is not complete, then we have to replace the coefficients of the missing terms by 0. Likewise, say if there was no x squared term, then we have to replace 0 here while writing the coefficients. So this is the first row, and then you give a sign like this. Now when to divide this by x minus 2, the divisor is x minus 2, we write the constant 2 here. How to determine this constant? You just equate this divisor to 0. If we equate x minus 2 equal to 0, the value of x becomes 2, so we take that number here. If it is x plus 2 instead, then equating x plus 2 equal to 0 gives x equal to minus 2, then we have to write minus 2. We have to consider minus 2 as a constant here. Now the synthetic division says that below 1 we just repeat the number itself. Whatever be the first value, repeat here itself. Then multiply this with 2, that is 2 into 1, 2, and write the result here below minus 3. So we have 2 into 1, which is 2. So multiply this 2 and write down the result below minus 3. Then add this 2. So if you add this 2, minus 3 plus 2 gives you 1. Again follow the same procedure, that is multiply 2 with 1 and write the product below 4. So this is 2 into 1, 2. So again we write 2 below 4. then add this column, 4 plus 2 gives you 6, again multiply 2 with 6 which is 12, write it below minus 3. So 12 minus 3 gives you, just a minute, let me check it once because I am getting some different remainder here. 1 minus 3, 4 minus 3, this is 1, 2, sorry, this will be minus 1, minus 3 plus 2 is minus 1. So here we have minus 2, 2 into minus 1 is minus 2, 4 minus 2, this will be 2, finally 2 into 2, this will be 4 here, and 4 minus 3, if you add these two columns, finally you get 1. Now here in the final row, we give a partition mark before the last constant. Just give a partition mark here. Then the first three constants, that is 1, minus 1, 2, this row will give you the row coefficients. This is the coefficient row of the quotient polynomial, and the last constant will give you the remainder polynomial. That means here the quotient polynomial will have a polynomial of degree 1 less. As I discussed earlier, if I divide a polynomial gx by a polynomial fx, the degree of the quotient polynomial will be the difference of their degree. So here, as we are dividing gx by a linear polynomial that is of degree 1, so the quotient polynomial will have 1 degree lesser than gx. So we have a polynomial of second degree because gx has degree 3. We are dividing this by a linear polynomial which has degree 1. So the degree of quotient will be difference of the degrees, 3 minus 1, 2. So therefore this will be the coefficient of the x squared term. So since the quotient here, the quotient polynomial, it is a polynomial of degree 2. So we have x squared term, x term and a constant term. So these are the coefficients in descending order of degrees. So this coefficient of x square is 1. So we have 1 into x square, 1 into x square. The next coefficient of x is minus 1. So minus 1 into x, and finally the constant term is plus 2. So which gives us the quotient polynomial as x square minus x plus 2. So this is our quotient polynomial, and the remainder polynomial is given by the last number, that is 1. So if you check our previous example, the same thing we did in long division process. So we got the same quotient polynomial and the same remainder. So this is a far more shorter method, even a faster method to find directly the quotient as well as the remainder when you divide any polynomial by a linear polynomial. So this method is known as synthetic division. This is a synthetic division. By this method, we can find the quotient and remainder whenever you divide any polynomial by a linear polynomial. Let me give you another example of synthetic division. Say, let us consider an incomplete polynomial now. Say we consider a polynomial of 4th degree, say 3x to the power 4 minus 2x square plus 3. So here we have an incomplete polynomial. The dividend is incomplete because as you can see that the highest degree term is a 4th degree, but the 3rd degree term and the 1st degree terms are absent. So this is an incomplete polynomial. Now to divide gx by fx, that is x minus 2, the same polynomial x minus 2 by synthetic division. So first we write the coefficients of gx in descending order of the degrees, making this or treating this as a complete polynomial. So treating gx as a complete polynomial, the coefficient of the highest degree term, that is the 4th degree term, is 3. Then coefficient of the next highest degree term, that is 3rd degree term, is 0 because there is no 3rd degree term. Mind that you have to replace this by 0 because we are treating gx as a complete polynomial. Then the coefficient of the next highest degree term is minus 2, that is x square is minus 2. Then the next highest degree is a 1st degree term which is absent. So we again replace the coefficient by 0, and finally we have the constant term 3. So this is the first row. and then we follow the synthetic division method. So we write the constant 2 here, because again if we equate fx to 0, x minus 2 equal to 0, you get x equal to 2, so put the number 2. Then below 3 we write 3, then multiply 2 into 3, that is 6 here, add this column, so we have 6, again multiply 2 into 6, write it here, 12, add the column, so 12 minus 2 gives you 10, multiply 2 into 10 which is 20, add the column, so 20 plus 0 is 20, finally 2 times 20 is 40, and add this 2 we get 43. So again you give a partition mark here. So this gives us the coefficient row of the dividend of the quotient polynomial, sorry. So here the quotient polynomial will be of degree 3, because gx is of degree 4, fx is of degree 1, so the degree of quotient will be 4 minus 1, that is 3. So the quotient polynomial, if you call this qx, is a third degree polynomial. So 3, these are the coefficients in descending order of degree. So 3 is the coefficient of xs cube term, that is third degree term, so we have 3xs cube. Then the coefficient of second degree term will be 6, so we have plus 6x square. Then the coefficient of first degree term, that is the coefficient of x, is plus 10 here, so we have plus 10x, and finally the 0 degree term, that is the constant term, will be 20, and the remainder r is given by 43. So this is how to divide a polynomial by a linear polynomial by synthetic division method. Now if the divisor is not a linear polynomial, then also we can apply the continued synthetic division method, but that is a little more complicated process. So in that case it is preferable to apply the long division. So let me now divide two polynomials. When one is a polynomial of degree 4 and the divisor is a polynomial of degree 2. So say we divide x to the power 4 minus 3x square plus 2x minus 3 by a polynomial x square minus x plus 2. So now we divide a 4th degree polynomial by a quadratic polynomial by the long division process. So here to form the quotient, as I explained, the first term will be x square, because x square into x square gives you x4. So we multiply the entire divisor by x square, so this gives you x square into x square, that is x4, minus x into x square, which is minus x cube, then plus 2 into x square is plus 2x square. Then we subtract the two rows, change the sign here, minus plus minus, x4 terms get cancelled. So after that you write the third degree term first. When you write the resultant here, so write in descending order of degree. So xs cube is the highest degree term here, so write plus xs cube. Mind that we cannot add these two, because this is second degree term, this is the third degree term. So this column cannot be added. So first we write the third degree term with the changed sign, so this plus xs cube. Then you merge the second degree terms, that is minus 3x square, again minus 2x square, which gives you minus 5x square, and the first degree term 2x, the constant term minus 3. So plus 2x minus 3. Then maintain the same procedure. Now here the first term is x cube, so we have to write plus x here, because plus x multiplied by the first term of divisor, that is x square, gives you x cube. So multiply the entire divisor by x now. So we have x cube minus x square plus 2x. Again subtract, change the sign, minus plus minus, x cube terms get cancelled. Here x cube get cancelled. So here we have plus x square minus 5x square gives you minus 4x square. Then 2x minus 2x, these two also get cancelled, and finally we are left out with minus 3. Now we have minus 4x square. The first term of divisor is x square, so you have to put the constant minus 4 here. So while multiplying you get now minus 4x square minus minus plus 4x and minus 8. So again subtract. So the signs get changed here, plus minus plus 4x square get cancelled. So first you write the highest degree term, that is the x term, this is 4x with the change sign, so minus 4x and plus 8 minus 3 gives you 5. So now you see that the degree of this polynomial becomes less than that of the divisor polynomial. So when the degree of the difference polynomial becomes strictly less than that of the divisor polynomial, so then the division stops here. So this gives us the remainder then. So this is the remainder polynomial, that is minus 4x plus 5 is the remainder polynomial, because the degree of the divisor is 2 and here the degree is 1, so this stops the procedure. So here this is the quotient polynomial and this is the remainder polynomial. So this is how to divide one polynomial by another, provided the degree of the divisor is less than the degree of the dividend polynomial. In my next video, we shall be discussing factors of a polynomial and methods of factorizing one polynomial. What we mean by factor of a polynomial and how to factorize different polynomials. I hope this video is helpful to you. You can ask if you have any questions in the comment section. I shall answer them. And if you like this video, please subscribe to my channel. It will help my channel to grow. We shall be meeting soon in my next video with some more theories. Thank you all for watching.